take a deep breath and relax. Despite some sensational headlines circulating online, reports claiming that interstellar comet 3I/Atlas is breaking apart have been greatly exaggerated. Similarly, the occasional claims that radio signals linked to the comet indicate it is some kind of alien probe are not supported by evidence. In reality, everything observed about 3I/Atlas so far points to a natural, cometary origin. This doesn't make it any less remarkable. In fact, the unique characteristics of 3I/Atlas make it an extremely fascinating object for scientists and space enthusiasts alike. Even without invoking extraterrestrial technology, this comet provides insights into the early formation of planetary systems, the chemical diversity of the universe, and the dynamic processes that shape interstellar objects. What makes 3I/Atlas unusual is not its size or speed alone, but its composition. Observations using some of the largest and most advanced telescopes on Earth and in space have revealed that it contains a surprisingly high amount of nickel, a higher than usual proportion of carbon dioxide, and a relatively low abundance of the common carbon chain molecules typically seen in solar system comets. This composition suggests that the comet formed in a very different environment from anything in our own planetary system, possibly around a star in a distant, ancient galaxy. The comet is also red in color and covered with a layer of cosmic dust, which indicates that it has been exposed to intense cosmic radiation for billions of years. This long-term radiation exposure likely altered the surface chemistry of the comet, giving it the reddish hue and dusty appearance observed today. In addition to its unusual composition, 3I/Atlas is moving at an extraordinary speed compared to most solar system objects. Preliminary kinematic models suggest that it may have been traveling through interstellar space for as long as 11 billion years, meaning it could have formed when the universe was less than half its current age. This incredible age, combined with its unique chemical makeup, makes it a living relic of the early universe, a cosmic messenger carrying clues about the conditions and materials present in distant star systems long before our own sun even formed. For planetary scientists, this is akin to opening a time capsule that has traveled across the galaxy, offering a rare glimpse into processes that shaped planets and stars billions of years ago. Despite these exciting scientific opportunities, 3I/Atlas has been surrounded by speculation and rumors ever since its discovery on July 1, 2025. One of the most persistent narratives has been the idea that the comet could be an alien spacecraft sent to survey our solar system. This theory gained attention largely due to Harvard astrophysicist Avi Loeb, who has previously suggested that the first interstellar object discovered, 1I/Oumuamua, might have been artificial. Loeb has since extended his arguments to 3I/Atlas, highlighting what he sees as anomalies that could indicate an intelligent origin. While these ideas are provocative and capture the public imagination, they have been met with skepticism from the broader scientific community. A detailed rebuttal of Loeb's claims was recently published by Jason Wright, an astronomer at Penn State University. Wright carefully examined the so-called anomalies cited by Loeb and found that only a handful are genuinely unusual from a planetary science perspective. Specifically, Wright identifies four anomalies that warrant attention: the high nickel content, the extreme polarization of light reflected from the comet's surface, the unusual water abundance, and the rapid brightening observed as it approached the sun. Importantly, each of these phenomena can be explained within the context of cometary science. Nickel enrichment, for example, is rare but not unprecedented, and can occur naturally under certain formation conditions. Polarization can be influenced by the texture and composition of surface dust. Variations in water abundance and sudden brightening are common behaviors in comets as they respond to the sun's heat, causing ice and volatile gases to sublimate. Cometary behavior in the inner solar system provides additional context for understanding these observations. Comets are known to break apart when they approach the sun, often due to the buildup of pressure from sublimating ices or the mechanical stress induced by increased rotation. This process can cause a comet to fracture or fragment dramatically, sometimes appearing to observers as though the object is disintegrating. However, such breakups are a natural part of a comet's life cycle and provide further confirmation that the object is, indeed, a comet. Ironically, if 3I/Atlas were to break apart, it would serve as proof of its cometary nature. On the other hand, remaining fully intact, while still consistent with cometary physics, is sometimes used by proponents of the alien probe hypothesis to argue for artificial origin. Most planetary scientists, however, find these claims unconvincing, emphasizing that natural explanations are both more likely and better supported by evidence. Visual observations of 3I/Atlas further support the view that it is a natural comet. According to cometary scientist Qiqing Zhang of Lowell Observatory in Arizona, images obtained from multiple telescopes show a healthy-looking nucleus with no clear signs of fragmentation. The comet appears dusty and active, with a faint tail and coma indicative of sublimating material. There is no evidence of structural anomalies that would suggest artificial construction or operation. Such images align well with the behavior of known comets, reinforcing the consensus among experts that 3I/Atlas is a highly unusual, yet entirely natural object. The excitement around 3I/Atlas stems not from sensational claims of alien technology, but from the unique scientific opportunities it presents. As a comet with a composition unlike anything previously observed in our solar system, it challenges existing models of comet formation and evolution. Its unusual mix of nickel and carbon dioxide, combined with a dearth of common carbon chain molecules, hints at a chemical diversity in the universe that is far greater than previously appreciated. Studying this object can improve our understanding of how comets form in different stellar environments, how they are altered by billions of years of cosmic radiation, and how interstellar objects can survive long journeys across the galaxy without being destroyed. Moreover, 3I/Atlas offers a chance to refine our understanding of cometary dynamics. Its extreme speed and trajectory provide a natural laboratory for studying the interactions between comets and solar radiation, as well as the gravitational influences of the Sun and planets. Observing its activity as it passes through the inner solar system allows scientists to test predictions about sublimation rates, tail formation, and fragmentation processes. Each observation, measurement, and image contributes to a growing body of knowledge that will inform future studies of interstellar objects and the early solar systems they originated from. In conclusion, while the idea of 3I/Atlas being an alien probe captures headlines and sparks the imagination, the evidence points to a far more plausible and fascinating reality. It is a natural interstellar comet unlike any we have studied before. Its high nickel content, unusual chemical composition, red dusty surface, rapid motion, and ancient age all make it a remarkable object. But none of these characteristics require an extraterrestrial explanation. By focusing on the comet's actual scientific anomalies, researchers can gain profound insights into the formation and evolution of planetary systems across the galaxy. As studies continue and more data is collected, 3I/Atlas will remain a source of excitement and discovery, proving that nature itself is capable of producing phenomena as intriguing and mysterious as any science fiction story. In the end, the comet's value lies not in the fantasies it inspires, but in the knowledge and wonder it brings to our understanding of the universe.